projects. In this video, we are going to explain about a project titled ABNet Adaptive Balance Network Multiscale Object Detection in Remote Sensing Imagery. So now coming to the introduction part. In the field of remote sensing, precise identification of objects within extensive and intricate images is of great significance for a variety of applications spanning from environmental observation to urban development and disaster management. Nonetheless, remote sensing images bring about distinctive hurdles, including a broad range of object sizes and irregular class distributions, which render object detection a challenging undertaking. To tackle these obstacles, our study presents ABNet, an adaptive balance network designed for detecting objects at multiple scales in remote sensing images. So now coming to the objective part for this project. The goal of the study titled ABNet, that is Adaptive Balance Network for Multiscale Object Detection in Remote Sensing Imagery, comprise several central intentions. First, enhance multiple object detection. The primary aim is to elevate the precision and dependability of detecting objects at varying scales within remote sensing imagery. Second, here we have mitigating class imbalance. The research strives to address the issue of class imbalance in remote sensing object detection. Conventional models may be encounter difficulties while identifying less common objects in the images. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and matplotlib and c1 for visualization are important. Second, here we have exploring the dataset, satellite object image detection dataset. In this step, you inspect the dataset related to satellite object image detection to understand its content, structure and characteristics. Then we have installing the packages required for YOLO V5 in Colab. When using Colab, that is Google Collaboratory, you set up and install the specific packages and dependencies which is necessary for the YOLO V5 or deep learning model for object detection. Then we have processing the data based on the YOLO V5 model. Data pre-processing tasks are conducted to prepare the dataset for use with the YOLO V5 model. This includes counting images, reading images and XML files, creating bounding boxes array, generating mask and resizing the image. Next, we have image data augmentation for faster RCNN. Augmentation techniques are applied to the image data to increase the variety in the dataset. This includes operations such as cropping, rotating and transforming images into arrays, enhancing the performance of faster RCNN. Then we have building the model in Colab. The YOLO V5 model and faster RCNN model are established and configured to perform satellite object detection. This involves defining the model architecture and setting its parameters. Next, here we have training the model. The model YOLO V5 or faster RCNN is trained on the pre-processed data to learn how to detect objects within the satellite images. Next, we have processing the image using Keras. Keras is used for image data processing. Image data generator is employed for various image transformations like rescaling, shearing, zooming, horizontal flipping and reshaping. These processes enhance the dataset's diversity. Next, we have extracting and splitting the data train and test set. The data is split into training and testing subsets to evaluate the model's performance and generalization capabilities. Next, we have building the model. Different backbone models like AlexNet, ZFNet, ResNet, ResNet 101, VGG16 are used as a base architecture for various object detection models, that are RICNN, RICADO, ABNet, other models. Next, here we have Flask framework with SQLite for sign-up and sign-in. The Flask web framework is integrated with an SQLite database to facilitate user registration and authentication, typically used for creating a web interface to access the image detection service securely. Next, we have user gives input as image. User provides an input image for object detection. The given input is pre-processed with trained model and which is used for detection. The user provided image undergoes pre-processing to ensure it is in the right format. Then the trained model is applied to identify and locate objects within the image. Next, here we have the segmented each object and put bounding box. Once detected, the objects are segmented and enclosed within the bounding boxes for visualization and further analysis. Last, here we have final outcome is displayed. The results, including the detected objects and their bounding boxes, are presented to the user, allowing them to view and work with the detected objects. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Another folder named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. So next here we have .ipynb file, which is a Jupyter notebook file which contains a combination of code, class, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. The next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing input requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. The next here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here, and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the class framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here. Now hit the enter button. So here you can see that this is our home page for the ABNet Adaptive Balance Network Multiscale Object Detection and Remote Sensing Imagery. So these are the features: YOLO v3 object detection and YOLO v5. There's a button for sign up. Just click on this button. Enter your username, name, email ID, phone number, and your password over here for doing registration. I have already done the registration, so I'm clicking on sign in button. Just enter the username and the password over here which you have created while doing the registration, and simply click on sign in button. So here you can see that it is asking for uploading any of the image. Just click on the choose file button and let me choose the image. So here you can see that we have to choose any one of the images from all these images. Suppose that I am choosing the second image, and now click on here open button. Click on upload. So it is detected as this that this is the playground. So depending upon the image you're providing over there, it will detect. Let's try with some other image. Now click on choose file button for uploading the image. Suppose that I am choosing now this image, and now click on open button. Click on upload. Here you can see that it is detecting as that these are the aeroplanes over here. So depending upon the image you're providing over there, it will detect about. This is the button for about. Just click on this button, and here you can see that these all are the features over here which they are providing. YOLO v3 accident detection and YOLO v5. By simply clicking on the sign out button, you can successfully log out with this. So now coming back to the conclusion part. The research on ABNet Adaptive Balance Network for Multiscale Object Detection and Remote Sensing Imagery concludes by emphasizing the remarkable progress achieved in the domain of object detection and remote sensing. It underscores the potential influence of this innovative approach. In this investigation, we have effectively introduced ABNet, a deep learning model crafted to address the distinctive challenges of object detection within remote sensing images. ABNet's capacity to flexibly adapt to multi-scale objects within intricate imagery stands as a noteworthy breakthrough. So here we have completed with our project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.